And in a great tradition of doing 2 episodes in one day and then not doing any for a week, I'm gonna solve some more puzzles. I'm still doing genuinely approachable pencil puzzles. So the next one is the 15th of February, and right away we have a genre I have never seen, Tawamurenga, often shortened to just Tawa, which is like Tapa, but I mean, well, it doesn't really look like Tapa. By Jovial. Rules. Shade some cells such that each shaded cell has at least one shaded cell directly beneath, except for shaded cells on the bottom row. So it's kind of like bricks in a wall. In a row, there may not exist a consecutive run of 3 or more shaded cells. So like 2 is okay, but 3 in a row is better. Okay. Clued cells cannot be shaded and represent the total number of shaded cells that share an edge with the clue. Cells containing a question mark can have any number of shaded cells around them, including 0. So question mark just says that it's unshaded. Okay, so yeah, we are building those kind of walls that roughly can stay on their own, and numbers give the number of shaded neighbors. Okay, example and then example again, but well, I am hoping that one of them is not an example. Example. So the numbers should be unshaded. The 6 just has 6 neighbors, so those are shaded. And we cannot have 3 in horizontal row. So those are unshaded. Okay. So for this 4, like they, yeah, almost all of them should be shaded, and if this one is shaded, then those 2 must be also shaded, and if it is unshaded, then everything else is shaded, so those 2 are shaded for sure. This shaded must stand on something, so this one is shaded, and then for this 2, this one must be unshaded. And then for this one to stay on something, this is shaded. Now we cannot have 3 shaded in a row, and now we have 4. And it was just done, but yeah, this one already has 1 shaded, so those are unshaded. Okay. Building a wall. Building a bigger wall. Okay, 0, everything is unshaded, the numbers are unshaded, the 6 must have 6 shaded neighbors, and we cannot have 3 in a row. This 3 just has 3 neighbors. Okay, this one cannot be shaded because it cannot propagate down, and this one cannot be shaded because it cannot propagate down, and those also. Now this 3 only has 3 neighbors left. Cannot shade this one because it would be 3 in a row. Now this 5 must have 5, this 2 already has 2, this 3 already has 3. Those must propagate down, this 2 already has 2. Propagate down further. Now this 2 is already satisfied. Further, and this 2 is satisfied. For this 3 we need 1 more. It cannot be this one because this one will be unshaded. Okay. Okay, this one should propagate further. For this 3, we have 4 options left. We cannot take both of those because that would be 3 in a row, so this one is shaded. This 2 is all shaded. Yeah, that part was easier. This one must be unshaded because it cannot stand on anything. So this one is shaded because 3. This one must be unshaded, but then those 2 must stand on something. This is unshaded because we cannot have 3 in a row. This one cannot be shaded because it cannot stand on anything. Now this 2 must have those 2. And we cannot shade this one because it would be 3 in a row. Okay. Interesting genre. The next puzzle is Stostone by Tyrgannus. This genre I have seen, but I don't remember the rules. Shade a single group of orthogonally connected cells in each region. Okay. A shaded cell in one region cannot share an edge orthogonally with a shaded cell in a different region. So, like, through the border, only one of the cells might be shaded. Regions with numbers must contain the indicated amount of shaded cells. So if we have a number, then that's the number of shaded cells. If all of the shaded groups were to fall straight down without changing shape, they must completely fill the bottom half of the grid. So it's kind of like Tetris. Hint: that last rule is often the one that takes some thought. I strongly suggest playing around with the example puzzle and pressing the drop blocks button. While Stostone puzzles can often be solved without needing to press drop blocks, it is a great visual way to see how your blocks are falling currently and what columns regions still need attention. Interesting. I have never used that button. Didn't even know that exists. Where is the button? Drop blocks. Okay, so if I press on it, if I hold it, it drops. And yes, the way it works is like Tetris. And if there was something, well, how will that work? Okay, so the blocks do not connect through the region borders because that cannot happen. Cannot have connected components that span several regions. Okay, so when the blocks drop, they do not change their columns. So in every column we have to blacken exactly half of the cells. So 3 cells for every column. So for example, if we look at those 2 columns, we have to shade like 3 plus 3, so it's 6, but this only says 5, so this one must be shaded. And in each region it is a connected group, so it must be 2 in this region. Now, the neighbors that are in different regions must be unshaded, because we cannot have two blackened cells near the border. Do I have to shade something in every region? A single group. So it cannot be 0. Is it true? All regions contain exactly one block. Yeah, there is a room has no shaded cells. It's a bad. Okay. So this one must be shaded, and this one is unshaded, and these three are shaded. Okay. Now in this column we already have 2 shaded cells, and we need 3. So among those 2 cells, at most 1 can be shaded. But then we need 4, so those 3 must be shaded, and 1 here also must be shaded, so this one must be unshaded. This one also must be unshaded because we already have 3 shaded here. Those are unshaded as neighbors. In this column we need 1 more. In this column we need 2 more. So this must be a triangle. Let's use the hint and hold drop blocks. So yeah, we need to fill that gap. And it must be done by shading this cell. If we shade this one instead, it will be bad. But also, like how I like to look at it is, I know that this cell is on the ground level when they drop, because it's the lowest one in its column. And so, like, the cell I will shade will also be on the ground level. They're in the same figure, so they must be on the same level before they drop. So that after, like, they will go down by the same distance, so they have to be on the same level before the drop also. Okay. Those are unshaded because border. In this column we have 2 cells left, both must be shaded. And now we need to shade 3 more in this column. And again, like, this cell will be on the ground, so the lowest one must be here. So it's like this. Okay. Now let's see the main puzzle. 4 must be connected, so we need to shade those 3 and 1 more. Here 4 must be connected, so those 2 are shaded. Also, our puzzle is 8 by 8, so we will have 4 blackened cells in every column. This 5 out of 6, it is in like this snaky shape. We didn't have any snake puzzles yet. Okay, interesting. So those must be shaded, and 1 more on the end. Also, I must mark as unshaded the neighbors of shaded cells that are in different regions. So in this region now we must shade this one, because there is nothing else left. And we finish the 4 region. In this 2, well, we cannot shade this one because it is a neighbor, but also if we shade it, then we cannot have 2 shaded connected in this region. They must be here. In this region we just have 2 left. And in this column we already have 4, so those must be unshaded, and now in this region just 3 left. And the last one in this region. So far so good. This is unshaded, and this one is shaded. Mark those. In this column we already have 4. Now in this region everything else must be shaded. In this region we need to shade something. In this column we have 1, 2, 3, so we need the fourth one. So this one must be unshaded because they must be connected inside the region. This one is unshaded because of neighbors, and we need to shade the fourth one in this column, also at least one in this region. This one is unshaded. In this column we already have 4 unshaded, so everything else must be shaded. This must propagate somewhere. We cannot shade this one because like those are the 2 top blocks. They must be on the same level. Like after we drop, but since in the same figure, they must be on the same level in the figure they are. And we need 2 more in this column, and like here, this is the second, this is the third in the column, and the 2 we will shade will be the first and second. So 2 seconds must be on the same level, and the first one is here. It's a very cute genre. The next puzzle, Tetro-Kinds by Freddie. Also haven't seen this one. I'm assuming there will be some tetrominoes. Rules. Divide the grid into regions of 4 orthogonally connected cells. Tetrominoes. A clue represents how many different shapes the regions touching the clue are in, counting rotations and reflections as the same. In particular, a clue does not necessarily give the number of regions surrounding it. So, for example, this one has 2 regions, but they're the same, they're both I. But the fourth must be like 4 different. And yeah, the story reminds us that there are 5 possible tetrominoes, LITSO. Divide into regions. The clues give number of different regions that touch. Okay, let's see the example. So the fourth must be like different regions and also different types of regions. The regions must be of size 4. These 2 also must have 2 different regions. So the top region must look like this. And therefore, like this one cannot be a T. And none of those can be T. This one is decided, right? I cannot... Let's make it bigger. I cannot connect here because that would be a 5. So this is a border, and it grows here. Now this one grows as an I in the only way possible. Now I can use this one clue to understand that this cell also must be in an I region, which decides it. This one looks like another T, but this T is in a different 4 clue. So far, so good. This grows here, and here I should have 3 different types, which means at least 3 different tetrominoes. This looks like an O because I have 4 cells and only 1 exit, so like I cannot split them. This is an O. Now I should use something about the types. Like this type cannot be T or S. It also cannot be O because it just can't. It cannot be I because that would like leave the grid. So it must be an L. L might be like this or like this. This one is bad because we will cut off those two cells. So it must be an L like this. Now those four are again like they only connect through this cell, so they must stay the same, and that's it. So this is an L, this is also an L, and this two has two different types. Okay, great. Okay, I think I have some understanding of this puzzle. Let's make it bigger right away. So the fours and twos on the border are great places to start. These two on the border also. And they need to grow, and we cannot connect like this because they must be different. They already have border between them, so this is an L. This one grows here, this grows here and here, cannot go back left. Those two must be different. Now those four must be different shapes, so it cannot be an L because L was here already. So it cannot go left or right, it must go further down. Now this one goes down, and it cannot be I because this two clue should have two different types, so this must be an L. Those two grow like this, they're different terminals, and they're actually different types. So this one is an I and this one is an L. This one already has an I. Interesting. So all those cells must be I's. But this is a 3. So those two cells have the same type, so those two must be different from each other and from this one. This must be an I. So it goes like this. This is also an I like this. And this one tells us that this is still an I. It goes like this. Now this 3 must have two different types. And we have another 3 here. Those two cells are in the same shape, so those two must be different. Okay, now let's look at like this region of 5 cells. It has entrance through this one, but I want 4. So, well, I mean, what I want to say is that I need to cut this one. So I need to cut 1 from those 5. And I cannot split them into several figures that go outside because they only have 1 entrance. Or you can just see that, like, if I add this cell, then one of those or both of them will be cut off from the world. So, yeah, I need to have this L. Okay, let's go back to where we started. This is an L and I, so this cannot be L, so it cannot go down, it must go right. And this one cannot go, I mean, it must be T. It cannot be O, and all others are already used, and we can draw a T only like this. So this one is also a T. Okay. Has to grow somewhere. I cannot draw a border here because then those figures will have to both grow, and I will only have 2 different terminals for this 3 clue. So I have to actually connect them, and it will be an I terminal. And now those two must be different. This is a 4 in enclosed space, so I just close them. Grows here, cannot connect here because this 3 must have 3 different types, but those 2 are both else, so it must be like this. Next puzzle. And the next one is Myopia by Eric Fox. I really like Myopia puzzles, or like Pintopia puzzles, the puzzles with those kind of clues. So, the rules. Connect some pairs of orthogonally adjacent dots to form a single non-intersecting loop. So just draw a loop, right? Connect pairs. Clued cells contain arrows indicating all of the orthogonal directions in which loop segment appears closest to the clued cell. So for a cell in which we have some arrows, there are four directions: up, down, left, right, and we look at the closest segment in each direction in the drawn loop, and we point out the directions which are for which the closest segment is the closest, is on the minimum distance. So, for example, for this cell, there is no segment up, there is no segment on the left, the segment on the right is on distance 2, but the segment down is in distance 1. So this is the only closest, so we only draw this arrow like this. For this cell, there is no segment on the right, the segment down is on distance 2, but the segments on the left and up on distances 1, so we only draw those two cells. So the arrows give us several types of information. I mean, it is all written as all the directions with minimum distance to closest segment, but it means that for all the directions that are given, the distance is the same, and for all the directions that are not given, the distance is strictly greater, maybe infinity if there is no segment. So we have what is called negative information. We know that something is not true because otherwise it would be given to us. Note, this last rule does mean that if in 2 or more directions there is a tie for the closest line segment, all of those directions are shown. Directions without arrows must have the nearest segment be further than directions with arrows. That's what I was trying to explain, but maybe Eric Fox did it better. Probably. Okay, let's look at the example. So, actually, I start those puzzles with looking at the negative information we get, because it's easy to use right away. For example, I know that I cannot have a segment here, because this is the closest something can be, and I know that the closest segment in that direction is not the closest one. So for every clue cell, I can mark all the directions that are not given arrows for with X's. And also I must draw a loop, so I cannot use this segment because it will not be able to leave. And again, this segment also cannot be used. The same here and here and here. Okay, now for the fourth clue. I have arrows in all directions, which kind of means that I don't get any negative information. But what will happen if the closest segment is actually on distance 1. So they all must be on distance 1. But then that is all the loop I can get. So if I have any other clues that... okay, yeah, if I have an arrow, it means that there is one segment in this direction, and this is not the case here. So those must also be x's. And like for any big enough puzzle, that would be the case. So for clue also give us some x's right away, even though like technically it's not the same kind of x's we get from the all other clues. Now here we have this kind of cul-de-sac, and we can see that either I get both of those segments or none of them if I just don't go around that cell. But if I get none, then I don't have a closer segment in this direction, which is not allowed, so I must have both. And to draw a bigger loop, must have this. Also, like from this clue, I understand that in the up direction, I also must have a segment on distance 1. Okay, we can look again at this for clue. In the right direction or in down direction, we can see that like there were 3 possible places for a segment, but 2 of them are already x'd out, so we have to take the last one, and also take the segment on distance 2 in all the directions because of the for clue. Now here I will not be able to have like distance 1 because that would create a fork. So those must be x's. And in this case, like I already know about all the x's in other directions, but like if it was like in the middle of the grid, I would get another x here because like I know that the minimum distance is not 1, so it's at least 2. So the distance that is not the minimum 1 must be at least 3. So I get like 1 more x in the directions that are not given. Now here I can draw a loop in only one way. So I get a segment on distance 2 here and therefore here because of this clue. Cannot go down, must go up, must continue the loop here. Here again, like the same situation as I had here, I must go into this cul-de-sac, and then because of this clue I know that if this is distance 1, then this is also distance 1, and then just end the puzzle. For pen I should not forget to increase the puzzle before solving, because very small for some reason. So yeah, making this bigger. Okay, starting with marking all of the negative information, and here we can see that negative information from this clue affects the positive direction of this clue, so I actually get 2 x's in the negative directions, and I will not be able to get here and here, so a lot of information right away. Continuing to mark the negative information, not able to use this and then this, and now I have 2 x's in the positive direction, so in the negative direction I can mark 3 x's. This is just great. The 4, again, I cannot draw this one square, there are some arrows outside, and like in this direction I only have 1 more possible segment, so I'll have to take this distance too. This clue gives us all of that. Here's the only way to continue the loop. this clue looks at the border of the grid. There's just only one option. Must take it, therefore must take this one. Continuing the loop here, distance 1 here, so going to the other direction marked by the clue. Okay. Now here I have 3 endpoints. I need the fourth one, so, or like remove one of those. You can look at it either way. Either way we are getting this segment, because otherwise I have like 3 endpoints in this closed area, which is not good. It should be even number of them, and connect those two. For this clue, we can look at negative directions like up or right and see that we have a segment on distance 2, so the closest one must be closer than that, therefore on distance 1. Okay, another cul-de-sac here, just like in the example puzzle. Cannot close the loop. Have distance 1 here, so it should be distance 1 here. Cannot use any of those. So for this clue, the closest segment I can take is 1, 2, 3, 4. So 1, 2, 3, 4 in the other direction, and the negative constraint of 1, 2, 3, 4. Because if I take this fourth one, then there should have been an arrow up here. This is blocked, so in the negative direction for this clue I should have 2, so this one is blocked, then this one is blocked, because from this clue the negative direction of 2. Here. Now in this cul-de-sac I'm taking it because I need a segment in that direction. Cannot close the loop here or here. For this clue, there is a segment in distance of 2 in the negative direction, so in the positive should be distance 1. Distance 1 for this clue. If I go right here, I then go up and close the loop, so I'm not doing that. I'm going up instead here. Continuing the loop here. So this endpoint will eventually arrive here, so something like this. And to satisfy this clue, I think I have to take this, right? Yeah, this is on distance 3, so this must be on distance 2 or less. So I'm taking this. Cannot close the loop here. And now all this is one big pass, so I cannot close this loop here or here. Continuing both. Shouldn't go down here. For this clue in the down direction, I must take something, so I'm taking the only one left, which is distance 1. Then this go up in the only way, and for this clue the distance is 1. And just finishing the loop here. Must connect like this. Always satisfying for me. I don't know. I just love this kind of clues with arrows. Myopia type of clues. Very, very nice for me. Okay, I think that's good for today. Thanks for watching. Also, if you want to try some harder and or competitive puzzles, on Logic Masters India there is a Puzzle Ramayan series, and the next contest will start tomorrow, I think, 14th March to 20th March, and today is 13th. Yeah, so this contest starts tomorrow. It will continue for 6 or 7 days. The length of the contest is just an hour, and you can start at any time in this window. And there will be some nice puzzles, some number puzzles, and some genres that were invented by Indian authors, which is pretty cool. Here's the instruction booklet, so yeah, you can look at examples, like rules and examples of puzzles that will be in this contest, and then you can try your hand at competitive puzzling. Thanks for watching. Bye.